And hello everyone, welcome back to another nim tutorial. In this tutorial, we'll be taking a look at the math module in nim. Alright, so let's import the math module, and we should actually start using this std to specify it from the standard library. I've been not using it for a while, but we should actually be using that when we import. Now here, let's just get a few constants we can get from this math module, such as echo e. And we can actually just echo a bunch of things here. Then we can get max float 32 precision. And I'll explain most of these in a second. Max float 64 precision, pi, tau, inf, negative inf, and nan. Alright, now let's just print them out so we can get values. There we go. So let's explain these. This E returns Euler's number. This max float 32 precision returns the max amount of digits after the decimal that can be trusted in a float. Because as you know, with computers, they have a certain length of precision that can be allowed. And like if you have a 32-bit float, then only 8 values after the decimal can be trusted to be accurate. After that, accuracy is questionable. With 64, there's 16. Pi will give you pi. Tau will, I assume, give you tau or whatever that is. Inf is basically infinity. And negative inf is negative infinity. So you have infinity and negative infinity in nim. And then nan stands for not a number. So if something is not a number, it is nan. Cool. Now similarly, we can have mathematical functions such as, let's say, 2 to the power of 6. We all know this. If we were to run this, we'll get 2 to the power of 6, which is 64. We could also use pow. And let's say 5 to the power of 2 this time. So this is the same as what we just had. But note it should use floating point values. There we go. So it's the same as what we just had, but now it's using pow, and it also requires floating point values. Let's also use sqrt for square root, and this also needs a floating point value, and that will be 5. So the square root of 25 is 5. We also have round, which will round a floating point value to an integer, or to its closest value. So let's say 3.5. We also have floor and ceil, and we'll actually get to both of them. So floor and ceil. And now, if we were to run this, we'll get 4.0, 3.0, and 4.0. So round will round it to its nearest whole number. So this will be 4 in this case. Floor will always round down. So even if I make this 3.9, it will go down to 3. And ceil will always round up. So even if I go 3.1, it will always round up. So we'll still get the same values because ceil always rounds up, floor always rounds down, and round rounds up or down depending on this value here. 5 means up, 4 or less means down. We can also have this, and then we can say trunc, and this will truncate this value. So if you run it now, we'll only get 3.0. So we'll basically remove this in part here. We also have a nice function is power of 2, and it will check if this is part of the powers of 2. So let's say 16, and we'll get true because 16 is power of 2. But if we say 17, then we'll get false. We have copy, sign, and let's say we have 10 and negative 1.0, and both of these should be floats, I'm believing. Now what this will do, and take note, this is only available in newer versions of nim, so make sure you have version of nim 1.6 or higher. So this will copy this negative symbol from this value here. So it will copy the symbol, the sign, from this value to there. So it will make this negative 10. It copies that sign. And I believe if we go negative 10 here, and we just hit 1.0, then it will become a positive value. So we'll copy the sign that's provided here. You have cum-summed, and here if you pass in an array 1, 2, 3, 4, it will calculate the combined values of an array. So in this case, 1 plus 2, that's 3, 3 plus 3, that's 6, 6 plus 4, that's 10. So it will give us 10. So if we run this, so what's happening here is we get 1, and then 1 plus 2, that will give us 3. And then 3 plus 3, that will give us 6, and then 6 plus 4, that will give us 10. So that's kind of how it works. Each value takes the cumulative value of the previous values and adds them together. We can also convert radians to degrees, so rad to dig for radians to degrees. I'm not going to get too deep into what radians are. Essentially, you don't need to know what they are unless you really need to work with them. And this is of course not part of cum-summed. We can just run this and we get 89.994 degrees. We can also convert degrees to radians. And now let's say we had 90.2 degrees, that will give us 1.57 radians. We can also do GCD and get the greatest common divisor. So 12, 8, if we run that, we'll get 4. So both of them can be divided by 4. And that is the largest they can be divided by. We also have floor mod, and this will floor modulo. So if we were to say 8 and 3, we will get 2. And basically it just means it will return an integer and not a floating point value. Same with div, and this should be div. So that will return 2. If you were to just do 8 divided by 3, then you'll get 2.666. All right. Now the next section is going to be for math lovers. And yeah, let's get to the more interesting part. So these are most of the things I don't really understand, but it's just to show you that they exist inside of nim. So we can say echo inf.isNone. And basically this will return false because infinite is a number. So isNone will just check if this is a number. Infinite is a number in nim, so it will return false because it's not isNone. This will check if it is not a number. However, you could do none and compare that to isNone, and it will be true because not a number is not a number. And then here we have sum, and this is like cum-summed like we did before. However, this time it won't return an array, it will return a value. So let's say 1, 2, 3, 4. Now if we were to run this, we'll get 10. And we also have prod, which is the same as a sum, but instead of adding, it will times. So it will 1 times 2, that's 2, 2 times 3, that is 6, 6 times 4, and then we'll get our value, 24. We do have things like cos for cosine, so 0.15, and then we'll get a value from that. Hyperbolic cosine, so cos h, and here we could maybe just put 1.0. We also have sin, tan, cube root, so this will get a cube root of the value. So basically this cube root is the same as saying floor sqrt, and then whatever the value is we put in. So let's say 8 for example, and then here let's just go 8.0. So this is the same as saying that essentially. And then we also have binom, which is the binomial coefficient. We have fac, which calculates the factorial of a positive number, something a little bit more easier to understand. And then we also have log, which computes the logarithm of x to the base. So let's say 10.0 and 2.0, and then let's go 6 and 2, For ton, we can say 10.0, and we can say the same for sin. Alright, for those of you who understood most of this, well done. And yeah, here's a few examples of the output. Great. And that is that for the maths module in NIM. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next NIM tutorial.